Alright. Let me pull up the stream and stuff. Right. Looks good. Pull up in here too. Yeah, it's here. Alright. Right. Looks good. Alright, audio sounds nice. What would we just say? Discord. Make that a pin message. Alright, that should be good. Just say a couple more things. Oh, he's like set up paint, so you might use it, may or may not. I don't know. I tend to use it sometimes, once in a while. Obsidian. Got code. Probably not gonna be doing much with this anyways, but yeah, probably not much with that. Just one more second, guys. Yeah, honestly, I don't know how these streams will fare. I don't know if they'll be boring or any better than my normal streams that I do with just coding. I mean, we could code stuff here too, it depends. I just need to kind of figure out what exactly. This is kind of just like a test run to see how these streams are. Yeah, so I'm not entirely sure how these streams are gonna go. Let me just let me put this stream. Let me put the stream in the Discord. What's up from Kaio? What's up, man? Welcome to the stream. It's going pretty good. I have to study the next phase of the compiler, so I can't code the compiler for a bit. But the streams have been going well, so I thought I'd just test it out and see how regular studying streams might be, if they're boring or whether they're nice. I don't know. It's just like a test run to see. Because we're in the middle of the phases between the compiler, so kind of difficult to tell what I'll do. But yeah, the parser works. The parser works pretty fine right now. I will show the compiler test real quick. So this is the REPL that we're in, right? So let's say we're making x equals 3. We'll show that it's a variable decoration, and then shows a literal value, just like how the tree is built. Let's do something more sophisticated, maybe x equals to y, or something like that. And we'll say like a block, or not, a to z equals 4. Something like that. Let's see. Yeah, so we got the if node, right? And then we got the binary operation, which just does parsing on two variables here, x and y. And then we can see we entered a block statement where our variable declaration is. So it seems to be going good. I tested it out with a couple other things too, and it seems to be working really well. Even in the case of like the bad stuff where it's not right, we need a variable name, it's not a valid variable name. If we forget like a semicolon, expected semicolon after initializer. Int main. Oh, I don't think I've tested function call. Let's try that. Int main. block if x is greater than 0. Oh, missing a parentheses. Okay, interesting. I want to test out first just regular function if the functions are working, then I'll do the missing parentheses call. So if the x plus plus, well, we don't have plus 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 in our language yet. It might not recognize that. So I'm literally just gonna say x is equal to x plus 1. And then it should be, since this is one block, then that's the other block, so it should be 2. And I assume most of the, yeah, let's see. Yo, what's up, Swan? How you doing, bro? Let's see. Alright, so if, alright, looks like the binary op is going fine. Identifier x literal. It's entering the block. Looks like it's not understanding the function calls that well. I guess I haven't really done that yet. But let's see. Yeah, just align one part. Which part? So, okay, wait. Initializer. I thought we put it though. X plus 1. I guess it's seeing this as a different initializer as that. I don't know exactly. That might be fixed with the IR though. I don't know for sure. Alright, block, enters the block, expression statement. Okay, binary op, x. Okay, so it looks like it's adding it well. Yeah, let me do that right now with the function call. Without a function, but a missing parentheses. Yeah, that should work. I think I tested that out before. Let's just do x equals x y. That should work. Missing parentheses. And we'll just say the block right there. Yeah, expected parentheses after condition. That should work because where did I put my, it should be up or yeah, up here. The if statement right here, we make sure that tokens are consumed, and if not, it returns an error statement for the left and right parentheses before the expression. Left parentheses, expression, right parentheses, so we make sure that's covered. I don't know what's going on with the function, why it's not recognizing a function. Let me see functions. Maybe we can fix that before we start setting stuff. Let me see. Function should be... yeah, it should be in the prep parsing part, so let me see. Let me see if I can write something. So let's just say, so it's going for function, args. So let's say, let's do a couple of arguments. Let's say like the function name is like function or something. And let's say argument 1, argument 2, argument 3. Does it actually work properly here? Is something going wrong? Oh yeah, wait, sorry. X, Y, Z. Oh no, function calls work. Okay, no, okay, this is for function calls. I haven't implemented functions like this yet. Okay, that's why it's not working here. Alright, that makes, yeah. I forgot. Okay. Because it should be right. The logic should be right, so I was confused for a second. Yeah. Alright, looks like everything works for the parser though. Yeah, I need to implement function declarations, which will be in a later part, I believe. probably get that on later part. Yeah, it seems to be going fine for the REPL, and also testing a file. In my class, we didn't need to implement functions at all. Yeah, they're a bit tricky, but I probably will implement functions. I didn't realize you were taking a class in uni for that. I'm assuming it's uni that you're taking the class at. But I did it for the parser. I didn't implement the AST2. Interesting. Well, for the next part, for the IR, we actually need to walk the AST, so that's why I need to have it. Honestly, I don't know what to do for today's stream. We have a couple of choices. Just going through random C++ stuff, because I have to learn the nuances and everything of C++ still. DSA is there, or just continuing on compilers, reading. Interesting. For my school, it is mandatory, it's an elective. Yeah, kind of just to practice, get better at coding, and also maybe in the future if I get roles for the compiler, I could also. I'm interested in it a lot, so it's very fun to learn about this stuff. So I might go down a rabbit hole learning a lot of stuff about it and hopefully get a role. Who knows though? We will see. And I also need to write notes about intermediate representation. We'll probably resume streams for coding the compiler maybe in a couple days. Depends on how long I take to actually understand what's going on. But yeah. I mean, I guess we can just go through some C++ first. Just to kind of see. I have a lot to learn about it. We'll see how the stream goes. If it was a productive stream, then maybe I'll do more of these streams. If not, then we'll probably just do coding streams, just regular, no learning streams. Banks uses logic? Oh, really? Interesting. I didn't know Banks uses logic. But yeah, off the top of my head here, I don't even know like what these are, to be honest. I've heard of them a lot, but I just haven't looked into them. I don't know what unions are either. These I may know, not to a big extent though. So we should probably go through it this chapter. There's a lot I have to learn. To be honest, I know like the basics of like arrays, vectors, smart pointers, classes, structs, all the basics, but I haven't been going into it too deep. So that's where Learn CPP comes in, so I can actually get better at this stuff. Yeah, we can just probably go through each one and just see. They probably have like stuff at the end, right? Maybe for some lessons they might have some stuff to practice at the end, possibly. But yeah, I'm interested in seeing what lvalue, rvalues are. Lexical analyzer and parser can be used for documents, not only programming languages. They don't really implement it from scratch. Interesting. Yeah, that does make sense. I assume also like database engines might also be using that a lot too, to get the syntax for databases. And possibly maybe even the back end of databases may overlap. I do have like a database research opportunity. The professor said I needed to learn like something called, what was it even called again? It was like relational algebra or something. Yeah, something like that. I need to learn that, and then he'd let me do the project. join the project. I don't know what that is. I've never even heard of relational algebra, but I guess that's a thing for query languages and DBMS. For example, OpenCV, that is a digital image processing, Flex. Ah, interesting. I didn't realize even for like the video processing, OpenCV is like that one, the one thing we're on. It's like a Python library, I think, right? I'm not sure. Like where you use your camera. We can use your camera and make some projects with that. Maybe I'm thinking of something else. You can use it in C++ too. Isn't it probably, it's probably written in C++, right? To be honest. I probably think that it would be written in C++. Expressions produce side effects, that outlive the expression. Yeah, it's that one, yeah. I think I've tinkered with it like in a vibe coding thing. I don't know it like well though. I just did it for once just to see how it works. But I totally forgot. Yeah, increment, pre-increment, okay. Type in a value category. With two int operands will produce an int result, so int is the type of this expression. Via type inference, int will then be used as a type of v1. Yeah, that makes sense. For example, if you have a GPU in your computer and you want to use it with OpenCV, you'll have to build the library locally. You need the flex install. It's crazy. That's very interesting stuff, though. Man, this stuff goes really deep. Not gonna lie, there's just so much stuff you can do. Let's see. All right, so x5. Yeah, we can't do that. There are only two possible value categories: lvalue and rvalue. All right, this is where we can learn what these are, because I have no idea what they are. GL value, PR value, and X value. That's interesting. Yo, what's up, Brady? No, it's not my first one. It's Python's my first one. Well, I guess in high school I did a little bit of Java for one class, but I didn't study it at all. I wasn't interested. But Python's where I really started to actually learn stuff in first year of college. And then now, second year of college, I am just doing C++, trying to learn more about that. Ideally, I can get something the third year summer, hopefully. Now, let's see. Assigning value 5 to variable x. How do people usually practice this stuff, though, if it doesn't give, like, any practice at the end? I mean, I assume, like, AI, you can ask AI to give it practice problems or something, but... No, I'm not making a game. I'm in the middle of making a compiler right now. Yeah, sometimes they do have quizzes, but not for every lesson. Sometimes it doesn't give a lesson, doesn't give a quiz at all. Just gotta take notes and keep it in mind. Yo, what's up, AJ Brady? Yeah, that's probably the best way. I do have notes for Obsidian. I just note whatever is noteworthy. Alright, so we'll probably see how the stream goes, if it's interesting or not. I mean, we probably can do, like, as we get better, we can probably do mock builds of some random things, I don't know. We also have DSA, I'll probably do that later in a bit. And then of course compiler, I have like a couple documents on compilers to read. What's up, EXO? Alright, where were we in this part? Oh, we were more down. Yeah, we were here. Alright, I've never even heard these three before, but I guess we'll find out someday. Okay, this is for move semantics. Okay, that's in like a later chapter. Way later chapter. Yeah, my Obsidian notes are actually uploaded. They're on my GitHub. You can go to my GitHub, repos. Should be here. Yeah, Obsidian. I have a bunch. All of them. I don't have stuff in like operating systems or networking. I haven't gotten to those concepts yet. But as I do, they will be filled. But for now, I have stuff in C++, a little bit compiler design, and computer architecture. So you can see those. When learning Rust, I spent time looking through various topics of the language. I didn't go top-down learning. Yeah, top-down learning is kind of boring if you just go through. That's why I learned like just basics of other concepts like classes, unique pointers, vectors, templates, etc. But now I have to learn the nuances using this learn CPP. This if I go on like a coding Jesus stream or something, dude, I'm gonna get cooked. If you ask me like knowledge round questions, like I'm cooked. So I have to learn stuff. Well, I guess it is a face reveal, but it's just, I mean, it's on there, it's public on there, so I guess it's not really a face reveal. I have my GitHub profile in the description and it's public, so let's see. All right, lvalue and rvalue, let's see what they are. Evaluates to an identifiable object or bit field. Interesting. How old are you? I'm 19. About to be 20 though, soon. Checking your GitHub, guess you have a lot in common? Guess so. I don't know what your GitHub has, but yeah. I appreciate the follow though. Yo, what's up, Cheese Wizard? What's up, man? Term identity is used by C++ standard, but is not well defined. An entity, such an object or function, that has an identity can be differentiated from other similar entities. Okay, entities. Interesting. Access via identifier, reference, or pointer. Yeah, this makes sense. Okay, so this expression is an lvalue. Okay, so okay. That's interesting, okay. Constants into language. Lvalue is going to subtypes. Modifiable lvalue. Non-modifiable. Okay, that's because it's const 6pr. Yeah, that makes sense. Let's see. Now an rvalue. Expression that is not an lvalue. Rvalue's expressions evaluate to a value. Okay, so it's okay. So it's expression that is not an lvalue. Literals, except C-style string literals, which are lvalues. House, why? Why are these not? In the return value, functions and operators that return by value. Rvalues aren't identifiable, meaning they have to be used immediately. Oh, so it's like that, okay. I shared a video about these values and how they can break invariants, more specifically how moves can break invariants. Interesting. To be honest, I don't know what invariance is. Maybe you'd like to explain it so I can see. Are you also going to be writing a linker, or do you plan on just using LD? I'm not sure yet. I probably won't write a linker. I'll probably just use some library or something, or some other application to get a linker. I don't know. I need to look into how to get that. I assume a linker is a totally different beast there to write, so it might be a lot of extra writing. But if I'm interested, maybe. It really depends on where this goes. What you're working on? Just learning more C++ stuff. We're right now in the middle of the compiler phases, so I have to learn the next phase, which is intermediate representation. But we do have a working parser. Detects any mistakes that we have. And it also detects the right syntax too. So yeah, it works for the most part. I tested it out a lot, so I think we're ready to move on to the next part after I finish learning the next phase. So we're kind of in like a break phase right now. I was just giving streaming a try for regular stuff to see how it goes, if it's productive or not. An invariant is a condition such property that remains true throughout a program's execution. Interesting. Okay. It remains true through a program's execution. Okay. What might be some examples of that? Of an invariant? I mean, probably not while true loops, right? Because you can break out a while true loop, so that's probably not an invariant. You can't break out of it if you write a condition inside. Yeah, probably not as productive, but it'll at least be fun. And maybe I'll learn some things that I might not have. I appreciate you joining the stream, Cheese Wizard. We'll see you later. Alright, rvalue. Yeah. Alright, so this is... Okay. Let's see like some examples here. Logan Smith on YT has a video. Interesting. Maybe you could send that in the Discord or something, so I can check it out later. Yo, what's up, Slava? How you doing, bro? Const double 1.2. 1.2 is an rvalue expression. Okay, let me... So this is an lvalue, right? Okay. But this is an rvalue. Well, not the whole thing, just the number inside of it. Okay, just a number inside of it. But in this case, this can be reused, so it's not, or rvalue is going to be lvalue. But you just can't modify it. Let's see some of the cases. Statcast int d. D is just that variable, right? The result of static casting D to an int is an rvalue expression. I assume it's because it's not stored into a specific place to reuse. It has to be used at the exact moment where we're using it. Well, I guess so. Yeah, let's read more about this. Let's see. Those answers because these expressions produce temporary values that are not identifiable objects. Interesting, okay. Probably not, to be honest. I'm probably just gonna write it fully in C++. What's up, Swan? How you doing, bro? Welcome back. Okay, wait, this is a temporary value, but it's being stored inside a variable. I guess it being stored in a variable doesn't matter. That doesn't matter for it being an rvalue. Yeah, for right now it's going to be similar to C, unless I decide to pivot and make the syntax like my own language, or it might be like a C style syntax, but it might be different features. Who knows? Only time will tell, I guess. Respect for understanding C++. Yeah, I really want to learn this stuff more. I'm just seeing how it goes doing it on stream. Okay, literal values are always going to be rvalues, except for C-style string literals that we saw earlier. And, okay, alright plus, yeah, is using those and returning that value. Let's see. Got some C++ experience, but far more in C. I'd be willing to help build this if you want. I probably won't be taking help at the beginning, maybe, because the beginning part is just about me learning. But if I decide to do something later, maybe I could take contributors, maybe later. But I'll take feedback though. Feedback is always appreciated. Let's see. How to differentiate lvalues and rvalues. You guys usually like if let statements. You can make one just to get if. I don't even know what if let is. Is that like declaring something? Like if you're declaring something? I've been a person who understands Bash and Python and theories on show. That's interesting. That's very interesting. Rule of thumb to identify lvalue and rvalue expressions. Lvalue expressions are those that evaluate to functions or identifiable objects, yes, including variables, that persist beyond the end of the expression. Okay. Yeah. Rvalue expressions are those that evaluate to values, including literals and temporary objects that do not persist beyond the end of the expression. Okay, so I assume that because this cannot be reused unless it's stored within a variable. Like you just can't reuse that part, like the return value, unless you rewrite it somewhere, I guess. That's why it's an rvalue. Temporary objects do not persist beyond the end of the expression. For a more complete list of Lvalue and rvalue expressions, you can consult technical documentation. Lvalue is something you can take the address of. Okay, yeah, because it's like a variable, or potentially like a struct declaration or something, or a vector, literally anything. And you can take address of those, but you can't take an address of that rvalue expression that we saw earlier. Okay, that's a better way to think about it, actually. That's a good way to think about it. I appreciate that from Kyle. X plus 5 is rvalue, yeah. But the variable that's storing that would be, like if you do x equals or y equals x plus 5, the y would be the Lvalue, but the actual literal computation would be the rvalue. What is going on here? This is like, I've heard of them. Yeah, Max, I've heard of them so many times, but I just haven't looked into them. So this is my first day of looking into Lvalue and rvalue to see what they even are. It's a bit tricky to think about, but I like the address thing. The Lvalue is something you can take the address of. That's pretty nice to think of. I'm running a shell. It's awful, but it works. There's currently no scripting capabilities, but I'm working on environment variables. Plan to make it similar to Bash's shell length, but no promises. Hey, good luck on that, Max. Good luck on that. I hope to see it one day and test it out. That's very true. C++ is a strange language full of people trying to use all the latest features, so every project becomes its own language. Yeah, that about sums it up. What is that notation? Int and is that like reference of a reference? Of r equals 5. Because 5 is an rvalue, the compiler won't return an error. If I int x equals 10, int and r equal x, we'll get an error. Interesting. It's very interesting. Macros, okay. Alright, so we got a template. Alright, so we have rvalue template reference, turn true. T and is an rvalue reference. Okay, wait, T and, or reference of T is an Lvalue reference. This overload will be preferred for Lvalues. Okay, but this is an rvalue reference. It says overload will be preferred for rvalues. I'm not really understanding the difference between these exactly. Did it explain up here? It's a pointer to a pointer, but for literals, the internal pointer is temporary. It says it's expression scoped, meaning it only lives within the expression it is evoked in. So this is just a temporary. In this case as well. The internal pointer, the pointer here is temporary. Okay, zoom in a bit. Not that much, but maybe it's like this. It looks a bit zoomed out on stream, so. This doesn't really explain it that well. Let me see. Helper macro, extra prints, whatever. Okay, that's fine. That's fine. The printing is fine. Maybe wrong, of course, but that's how I usually remember it. I mean, this is where AI is really good at kind of understanding, kind of helping us understand more. Let's just grab a random AI. So we can just say like, I'm having trouble. And is a value, and is a rvalue reference. And we can kind of just see what it says. Okay, reference to an object that already has an identity. Okay, that makes sense. Let's see this part. This one, reference that can bind to temporary / disposable values. So essentially just what you said there, Swan. No, I get that, but let's see. Can bind to, because 5 is an rvalue tempered. Okay, this makes sense now. Okay. This only binds to objects or variables that already are defined there, but you can't do it to literals because there are values. Okay. But let's see. This one. rvalue reference, let's see. rvalue reference prefers binding to temporaries. And this one, okay, this one binds to temporary values. Let me go back to that code. Here. Let's see. Okay, so essentially whatever they pass in, okay. Interesting. Let's see if there's any more here to look into. This is very weird, not gonna lie. But I kind of understand it. Yeah, but isn't dereference and reference of T? In Logan Smith's video, he explains invariance using a vector, has a pointer, length, and capacity. I do remember one of Coding Jesus' videos, he said that that's what a vector is comprised of. I remembered it ever since then. Pointer to the vector, the size, and its capacity. Invariants enforce illegal states of every type of object. So by giving a pointer to a literal gives undefined behavior, if not, it didn't move immediately. Interesting. Dude, this is a lot of interesting stuff, not gonna lie. I need to get better at this. Alright, let's see. Overload resolution, choose a better match. Let's see. Okay, so this explains the situation here. Pass an R value of the different function. Okay, so T, this one can't bind to it because it's a literal value, but this one is allowed to have that in. Okay, I think I'm getting a good, decent grasp on this, hopefully. Forwarding references, let's see what this part is. What's up, not a sandworm? Do C#? I have no reason to right now. Like if I got like a job in C# or like some opportunity where it has to use C#, maybe, but I don't see a point for me using it right now. Maybe as like a interest later, but yeah, probably not right now. I think C++ is gonna take enough of my time already. I think balancing another language might be too much. On top of compilers too, so that's gonna be too much if I do C# or any other language. Okay. This one can become a forwarding reference. Okay, but that's if you pass that to the X value. Wait, that's weird. That is very weird. Okay. If I can watch it on stream, I might. I think you can, right? Yeah. I don't think that really is a problem to watch a bit on stream. I can watch a bit on stream. I'm assuming you sent it in the Discord server, AJ Brady. We can watch that and probably get a better idea. Yeah, I mentioned Coding Jesus. Dude, Coding Jesus is the person who actually got me interested in learning C++. But not for quant, though. Just in general. Because I watched all his call-in streams. They seem very interesting. I was like, you know what? I wanna learn all this stuff. Seems very interesting. He's probably not the biggest tech YouTuber. How much does he have? Like, last time I checked, he's at 100 something, maybe 200 something. I don't know. Primogen is probably way bigger. He's probably in the millions. Alright, we can watch that video right after I look through the rest. To be honest, I don't know what this is, forwarding references. I can't seem to grasp my head around it, to be honest. Maybe watching a video on it will help or something, I don't know. That's a quest for another time. But I think I understand the gist of all of this. Have the typecast C. Implicit typecasting was done. Templates. Where is templates? Or is that in like? Okay. I think I understand. Let me see this part. Why seesaw string literal is no value. Since it is a literal value, let's see. Seesaw strings decay to a pointer. Decay to a pointer. Is that like the... I might be thinking of it wrong. Is that like the const char star? Const char array pointer or something? Might be wrong though. Might be thinking of something different. Is no value, thus has an address that can be stored in a pointer. Interesting. Arrays and literals will always decay to pointers and passage of functions. Wait, then. But if it does decay into a pointer, does that automatically make the thing an L value? Because in the case of this one, we did pass it in a function, like the 5. And it's a literal. Forgot if literals decay to pointers. Probably strings, right? He said, I mean, this says that only C-style string literals are the literals that decay to pointers. Because then probably this would be invalid, right? This would be an L value if any literal decays to a pointer to be an L value. Interesting. Alright, next one, probably should do watch the video or something. I believe you put it in here. This one, right? Moves are broken. I don't know how well stream might hear it, but we'll see. Let me get the video. Yeah, that's a long video. How much are we gonna watch? That is a long video.
Hello.
Let me see. I don't know how volume will work. I'm gonna stop the music part, but
This one's going to be kind of a spiritual sequel to my video about.
I guess you guys can tell me if you can hear it or not.
Among
probably.
other things, I argued that the design of constructors in C++ makes it easy to accidentally view your program in an invalid state. And I compared it to the approach taken in Rust, which is much simpler and neatly solves all the problems I brought up. In this video, we're going to do a very similar thing with move semantics in C++, where I'll argue that the details of how they're designed in C++ lead to your code having weaker invariants, worse performance than ideal, and more complexity. I'll compare it to the approach to moves that Rust takes, and once again, I'll argue that Rust's simpler approach also just makes everything better. Now, this might sound like I'm just being overly negative here about C++, so keep in mind, I like C++, I like move semantics, and this is all just a thinly veiled excuse to talk about cool stuff in a bunch of detail.
That's true. Probably won't put the speed.
So you hear a lot about invariants. I like talking about them. In this discussion, we'll take a bit of a lower level perspective on them. So recall that your computer's memory is made out of nothing more than ones and zeros. Those ones and zeros have no inherent meaning whatsoever. It's literally just the physical state that some silicon happens to be in. Now, your processor allows you to talk about those ones and zeros in groups of 8 called bytes. And your computer's memory, the physical address space, is just an incredibly large two-dimensional array of those bytes. I say two-dimensional because on the horizontal axis, we have the memory addresses of each byte. And then at each address, there's sort of a depth of 8 because there are 8 bits we can talk about located at that address. Now, once again, this memory is meaningless. It's formless and void. It's a blank canvas for us to paint meaning onto. We do that with our programming languages. Our programming languages talk about this memory at a slightly higher level. They give us tools called types for carving it up into meaningful chunks. For example, when you declare an unsigned 32-bit integer, your programming language creates a sort of facade overlaid on top of 4 of those meaningless bytes and says, okay, while this integer exists, these 4 bytes are going to be meaningfully linked together, and they're going to work together to represent all the different binary digits of this single logical integer. Your programming language coordinates that and lets you believe there really is an integer there, but there's not, at least in your CPU's eyes. And by the time the compiler has finished and your program is running, the facade is gone, and your program is just doing 4-byte integer operations that the compiler generated on a piece of raw, meaningless memory. This is one ability of types to be able to describe the shape and size of the pieces of data we'll be working on. For example, with a struct, we can talk about a larger chunk of memory that has multiple primitive pieces of data in it. But just knowing what memory we're allowed to talk about doesn't help us know how that memory should be used correctly within the larger context of our program. That's where invariants step in. So invariants are when there are patterns of zeros that you could write into the memory you have allocated for your type, but that you won't because they describe a state that is illegal. As an example, let's picture a dynamic array like std vector from C++. This vector of t has 3 fields, and each one has an invariant. The pointer
so what a vector is comprised of,
describes where the buffer we have allocated is located. The len says how many chunks of memory at the start of that buffer have had t's constructor run on them, and then the cap is the total
why did it go back? Or wait,
size of that buffer. So clearly we can't just write any ones and zeros into these fields. The ones and zeros we write have to reflect the truth of what has happened up until now with this vector. It's the job of the vector's implementation to protect these invariants at the level of the programming language and enforce that any modifications to its field still result in a valid state. This vector on screen is clearly empty. It has no allocated buffer, no constructed elements, no capacity. Now, it is physically possible for us to go in there and write a different value to the memory that underlies
So
the
empty arrays capacity
but I hope we can see
0.
how that could cause serious problems for us. Our vector would start reporting the wrong size, and depending on the exact implementation, we could easily start dereferencing null pointers or whatever else. So we've corrupted this vector by breaking its invariants, and we've completely lost the ability to trust that it will behave as we want it to. And that's the crux of it. Invariants are vital. Invariants are the structural unit of being able to reason about what your code does whatsoever. Your computer's memory, without invariants placed upon it by your code, might as well be filled with random ones and zeros, at which point we might as well have never written any code at all, because that's also how it already was before we started. That's obviously taking things to the extreme, but it is a sliding scale. Weak invariants lead to difficulty reasoning about your code and suboptimal performance, because both you and the compiler's optimizer have to spend more time checking for edge cases. Strong invariants simplify your logic and increase your code's robustness, and corner cases don't have to be accounted for because they don't exist. I'm going to show you a simple example of that. But first, I feel bad moving on from this section without pointing out that you should strive to reduce the number of illegal bit representations that your type has. You'll often hear people saying it this way. I literally could not possibly agree with this sentiment more, but it's a little out of scope for this video. Let's talk about it another time soon. Okay, example of strengthening invariance. So C++ has two ways to refer to an object that you know is sitting at a particular place in memory. There's the pointer on the left and the reference on the right. Now, these two language features are pretty similar, although the type of gray hair each one adds to your head is actually a little different, but they're both represented in memory as a 64-bit memory address, assuming of course you're on 64-bit. But one very salient difference is that pointers can be null and is well supported. There's even a special language keyword that denotes a unit value that can implicitly convert to a null pointer of any type. References, on the other hand, can't be null. Same representation as pointer in memory, but they add the invariant that the bit pattern of all zeros is illegal. And I can already hear that person typing that comment saying you actually can have a reference to null, to which I say, no, you actually can't have a reference to null. Any attempt to create a reference to null boils down to something like this. You have to create a null pointer and then dereference it to turn it into a reference. That means you are dereferencing null, and you can't do that. It's undefined behavior to dereference null, so by doing this, all bets are off and you can no longer
Okay. Alright, that's interesting. Okay.
about your code
Got
anyway.
it.
It's as bad as scribbling random bits all over the length field of our vector. Now, do I wish C++ made it a little harder to do something so bad?
I don't know why.
Definitely.
Max the
But this
speed back
invariant
to
is ironclad in the language, and it gives us power over a pointer's weaker invariant. Let's say you have a public API that needs to refer to some object to do its work. I'm purposefully using the word object for this type because there are a lot of types, especially if you're working in a more object-oriented way. They're just kind of used to passing around by pointer. But that means that the first thing you need to do in this public API is probably check for null. Maybe if we get a null, we just want to early out or otherwise fail in some way. Now, inside the happy path, you're going to pass the object along to some helper functions that help you carry out your actual logic. So what do these helper functions look like? Well, you might write them like this. They take the object by pointer and do whatever they do. But should they null check? I mean, we already null checked at the call site. It's wasteful to do it again. But having to know what the call site looks like while we're looking at these functions breaks the local reasoning and the encapsulation that's the whole point of using a function. And what if we add another call site later, and that call site expects us to check for null inside the helpers? So yeah, so we should check for null, right? That means in order to get safety and local reasoning for each function in isolation, we need a linear number of null checks throughout our call hierarchy. Also, what do we do if the null check fails? Especially this top one where
okay.
expected to return a value.
Now let's see what
space overhead, and with the full nice API of option, which makes it really hard to forget to null check. And then once we do null check, we unwrap the reference from the option, and everyone further along in our call hierarchy doesn't have to check anything. C++ could do this with optional references. It's not built into the compiler like it is in Rust, but the standard library could definitely implement it with template specialization. For reasons I don't really understand, they don't do that. In fact, they just make this a hard error. It's too bad. Also, it's not just references that could benefit from these kinds of niche optimizations, as Rust calls them. Really, any type with any invalid bit representations could, in theory, repurpose those and let optional use them for the empty state.
I might honestly continue the rest of this after I learn a bit more stuff, because I was following it for the most part until around 6 minutes, and then I started getting kind of lost, to be honest. For the most part, up till that part, I was kind of following it. Then I started getting lost. But I guess, yeah, that does seem like a good video. Let me put it in my watch later. I think I just need to understand more stuff first before I watch that. Alright, lvalue references. Alright, what is the... Okay, alright. For do something array where array is stack allocated, array will decay a pointer to its first element. Okay. Whereas if I pass do something to the reference of array, pass the pointer to the whole array, and the function signature needs to be do something char star size of array. Interesting. That's crazy. Linux contributions. That's crazy. Yeah, reference to an alias. Yeah. Okay, I get that part. Let's see. Also create references to functions. Those are done less often. I don't think I've seen this I don't think I've seen code that creates references to functions. Or at least I haven't seen any, but yeah. Linux uses 0 C++. Yeah, I assume so. That's because it's not as good as being able to create functions as values. I mean, I guess that kind of makes sense. I feel like it would be a long process, right? You'd have to actually get like the return value of that function depending on what you're passing. So for each time you call that reference, so it might be different. It might be kind of difficult for the compiler to do that. Yeah, okay. Value such a variable. Yeah, we get that part. Let's see. Let's keep going down. Does anyone know that SCB has kernel level access or not? I'm trying to bypass its security, and yeah, I know I can run in the VM. That is too risky. That is not my domain, to be honest. Maybe someone in chat knows, though. Okay. A value reference to a non-constant commonly is called a value reference. It also may be referred to as a value reference to a non-constant or non-constant value reference. Okay. Alright, okay, so these are Lvalue references. Exam browser thing. Is that for like your exams or what? Or am I just completely thinking of it wrong? Alright, type, that can be a reference, call it reference type. Okay. That makes sense. One of the things we can do with Lvalue reference type is create an Lvalue reference variable. Lvalue reference variable is a variable that acts as a reference to an Lvalue, usually another variable. Yo, I appreciate you joining the stream from Kyle. See you next time, man. After this page, you might go on to DSA. for a bit. A reference variable. Lvalue reference variable is a variable that acts as a reference to an lvalue. Okay. Yeah, okay, I think I got that part now. Defines ref as an lvalue reference to an int, which we then initialize with lvalue expression x. Thereafter, ref and x can be used synonymously. Yeah, I've seen this happen. Like, I don't know, Visual Studio keeps correcting it to go to attach to the variable name. But I mostly see it like this, but I don't know. But I guess, yeah, it's not a problem. It's not a problem then. That's what I thought he was trying to do, AJ Brady. I thought he was trying to, like, bypass some exam proctoring or something. Why not just study? I mean, I'm sure you can just get a good grade if you study for a couple days. Like cyber, like I didn't study much until the end, just like the last 3 days, and ended up well. Modifying values through a non-const value reference. In the above example, we show that we can use a reference to read the value of the object being referenced. We can also use a non-const reference to modify the value of the object being referenced. Let's see. Alright, so variable, alright, reference, okay, yeah. Actually, let's be like 6. It's x, okay, so x now has the value of 7 because we changed that. We changed that reference variable. Interesting, okay. Yeah, I think I got that now. I think he left, bro. Or no, he didn't leave. He just wants to sell in the dark web. That's crazy. That is crazy. Rule of 5? Isn't that like the one from semantics? Like, I don't know, like, exactly what it is, but like, I guess, like, you need like a copy constructor, move constructor, destructor, constructor, and some other thing. And there's also the rule of 3 and also the rule of 0 as well. I remember looking into them once, but I forgot because it's been a while. I just know they're related to move semantics. Reference initialization. To be honest, I guess it shouldn't be too surprised that people would sell stuff like that and people would buy stuff like that. Yeah, I guess you do you, I guess. Reference initialization. References are initialized using a form of initialization. Non-cones. Reference binding. Okay. Sometimes called referent. Alright, that's interesting. Okay. I got that. Lvalue references to void are disallowed with a point. Yeah. Makes sense. Reference will usually only bind to an object matching its reference type. Okay. Let's see some examples here. Int reference x. Alright. That's fine, but okay, so if you hit a double, it's invalid. And double towards an int. Okay. Then I have an alias for x. Signs. Stakes the value of y to x. I think equals 5. Okay, so I guess in here the value. Okay, so the value of x is being changed to the value of y, but we're not actually changing the reference to y. So y should still stay the same no matter what we do. Yeah, who really knows? Who knows, man? But also you have to realize that people can just do this for a hobby too, so. Okay. I think I understand for the most part. Independent lifetimes. Let's see what this last part is. Reference can be destroyed before the object it is referencing. Okay, okay. The object being referenced can be destroyed before the reference. Okay. When a reference is destroyed before the referent is not impacted. Yeah, that makes sense. We're not changing anything with the thing being referenced, the referent, but when the ref dies, I guess it points to garbage maybe? If the X dies. Or be a dangling reference, dangling pointer. That's where dangling pointers come into play, dangling reference and stuff. Okay, that's interesting. Passing a dangling reference leads to undefined behavior. So I assume it just points to some garbage, or we don't know what it could point to. It could point to anything. It was a veer thing. Just studying some C++ stuff. Just some random things. Right now in between the phases of the compiler, so I may or may not do streams like this. It depends, really. I don't know. I might just make it like development streams and not like learning streams. At least until I get better, so I can actually provide some value. So I can provide some value, but maybe. I'll see. Same thing that AOL cure cancer replaces all jobs in 6 months. Yeah, it's been like every 6 months they've been saying that. Yeah, that's true. You have chatters who can answer questions and provide insight. That's true. I have gotten quite a bit of insight today on some things. On some concepts. But I guess I probably should frame it better to probably do some coding as well. I'll probably do some coding with DSA, to be honest. Probably in a second after we finish this. I want to see if I can remember how to implement just a list from scratch. Blocks keyboard shortcuts, copy pasting, mouse, close it up in Windows if it can't minimize it. I'm assuming that's the software for the exams, the proctoring. They are pretty strict about that, yeah. You can't even control F to go into parts. Like if you remember a question name, you can't press Control F. It'll say not allowed to control F on the exam. So you have to go manually find the question. References aren't objects. It's not required to exist or occupy storage. If possible, the compiler will optimize reference away by replacing all occurrences of a reference with the reference. Oh, is that okay? Interesting. This isn't always possible. In such cases, references may require storage. Consider reference wrapper. Interesting. Alright, let's see. Let's see. Alright, so int x1, int reference 2x. Right, so this should just be 1, 1. Setting up it into y variable. Setting the reference, which doesn't set the reference to y, but it sets the value of x to y's value. So it should be x should be 2 now. Y should be 2. Y should be 3 now. X should be 2. Hopefully I got that. So here it should be, yeah, x should be 2. Y should be 3. Yeah, 3. Well, wait. It should take y's old value. So yeah, okay, so 2 and 3. So 1, 1, 2, 3. X is now 4. If you change the value itself, I assume the reference would change. Like the reference value. So probably 4 here. Let's see. 1, 1, 2, 2, 4, 4. So this one's not 3, so why? Let me see. We changed y to 3. Oh, it wasn't accessing y. Oh, that's my bad. I thought it was saying y here. Okay. Yeah, okay, y should be here. Y should be 3 here, but the reference was the reference to that. The reference to x will now be the value of y, which we got earlier. I just thought this was saying y. I just didn't read it properly. But yeah, I think we got a good grasp on that. Okay. Decent bit done. I think we can move over to DSA. I think we can. I did want to see one thing. So where did I leave off on DSA? I believe around 50 something. Like, let's see. No, not here. Let's see. Where do we? I know I did implement. I implemented this list code, but I don't remember, or I might remember. I don't know. It was a long time ago. It was like 4 weeks ago. So I might want to refresh on the list code here and probably try and implement it again. So I'll probably look at this and try and implement it. Just I'll copy the constructors and the constructor, destructor, and all the variables, the private member variables, and the public variables of public functions. Sorry, public functions and the private member variables over, and probably try and implement that. Yeah, probably. Let me just close this. Let's just open up a random thing. And I'll probably delete what I had before, what I did 4 weeks ago, and probably redo it. And see if I can remember. So in the header, let's just see the class, how they did, and then do that. I'm probably just gonna do pragma ones. I'm not gonna do the if not def and define stuff. Oh, speaking of that, Max said something in chat. Yeah, I remember Learn CPP said that Google does not allow pragma ones. They need proper header guards, like the proper header guards. I just do this. I mean, I don't see a problem. I don't really care for header guards, so I don't want to think about them too much. Alright. This might be bad, but let's see if I can actually do this. What are the includes? iStream, okay. I believe the next part after is linked lists. I have to read about that. I remember doing linked lists in Python, but probably C++ is different. You probably need like a pointer to the next. You probably need to use pointers. The data and then the pointer to the next node and so on. So I need to look at that again. Depends on if you want extensions or not. What do you mean by that? What are like the cases where you wouldn't want to use pragma once? Like the extensions, like what does that mean? Okay, so class list. Let's see. I believe they had, let's see, private. What do they have as the private member variables? They had likely count items, pointer to items. Okay, let's see. Pointer to the items. So this will essentially be the array just pointing to the, I believe I remember it's like pointing to the value of the array that we are in. Let's see. And the public, just a couple functions, and the constructor, destructor. Oh, okay. And the functions. get. So we're getting a value at index. What is it? Search, remove, and count. Insert too. Okay, insert. So take index and the value. Int search, which will just take the value. Making it all capital. Int index. And then our count. Okay. Alright. I guess that's all. Now let's see if I can implement this properly. I guess we can start with the int, the get function, probably. Include this.h. Perhaps legacy code bases. Yeah, that'd probably be the case. And we want it to be list. Alright, so we're getting a value at a certain index. So I guess if I guess yeah, so now we just need to return the value, so return. And what was the value? So m items. And it'll just be the index. Yeah, it should just be that. We don't need to check anything. That should be for that. Let's see, next function. Just insert. So I assume we're putting a value at a certain index. Alright, this is a weird part. Since we're using a pointer. Want to add bounds checking? Oh yeah, I totally forgot. Yeah. Well, I guess. Well, wouldn't it just be if it's greater than m count? We have the m count, so we don't need a new one. So if index is, I guess, just should be greater than or greater than or equal to. Well, if we're getting a value at a certain index, yeah, we want to check the other bound too, yeah. So index is less than 0. Like I should say, if not, or we can just say return or something. So we can say index less than 0, and then index is greater than or equal to the m count variable. Let me see. Oh, yeah. If that's the case, then just return. And yeah, I guess that should work. Alright, inserting a value at an index. This is weird because I think it should just return, that should just be 0, but I guess we can. the unsigned int, but they did give me int, regular int for the actual problem to do. So I guess they want me to do the bounce trigger process, probably. Alright, these are values, so let's see. We probably just need to check that same case. I'll just say 0 here, and then same case here. Well, this is void, so it's just gonna be returned. And I guess we can say bounds. Alright, this is the weird part, right? So using a pointer to the items array, we need to have an old array. I'm pretty sure what they had in this implementation was like an old array and a new array. Let's see if I can remember that properly, how to actually do that part. I believe they had like setting that old array value, I believe. Hopefully I'm remembering right. This is 4 weeks ago I did this. So into old array, and we're setting that back to items. Can we not do that? Well, I guess it needs to be that. And then we need to set a new, we need to increment m count by one. So we can make a new list and say, I'm so slow at this, but yeah, probably set like a new array. So we'll probably just set m items that we already have as our just as our m count value. Wait, so how do we do that? So we're just like m items. Possibly. I want to set this new array with the count. No, not like that though. Why am I forgetting this part? And it wouldn't just be setting it to m count though. Wait, how do I believe it was the new keyword, but I forgot the syntax for that part. I think they did like new and or something. No, new int. New int of items possibly. I'm forgetting this. I'm forgetting the way to actually say that. Or new int of m count, we'll say probably. Yeah, I think that's probably the way. That took a while, but hopefully that's the way. So this should be the old array, but now with the new count. Since we're inserting a value, we need to set that up by 1. Now I think we can check this for. Alright, what do we need to check? yeah, we just need to loop through. We need to loop through our current array that we have, and probably do an if check here. If our index is equal to our val, or no, index is equal to I, then we set the val at that current point. So let's see, probably just set up a normal, set it to I, and we'll do I is less than. Yeah, I'm allocating an int. This is the way that the book wanted me to do it. I did it 4 weeks ago, but I'm trying to see if I can remember. I'll go through this, after this I'll go through the two functions and see. I did this before exams, and then I want to see if I can remember it now. So I already did this problem, and this is the exact way that they did it. It's like an implementation of a list abstract data type. You probably would never use this, but like, it's just a practice. So m, it should be m items dot, not size, m items, well, just m count. No, it should just be m count. The value, the amount of elements within the array, and then plus I, and we'll see. So if we want to set our index, so if index equal to I, we want our values to be inserted into that. So how do we, I guess m items, m items I, like the value that we're at currently in the array, and we'd probably say, yeah, just val. Should be right. Well, wait, hold up. Okay. We also need to, since this is a new array that has nothing in it, so we want to create the array back up. So, okay, if it's like this, we will insert the value at there. Otherwise, we want to have j be our, what's that, like an int j, maybe. We'll set like an int j and call that our old array. Or wait, how are we gonna do that? No, not like that. That's just wrong. We just set like int j here and an old array j, and then plus j to keep looping, to keep going through the array, so it can rebuild our array back up. Yeah, it's a resizable array here. I'm just seeing if I can like think my way through it again. If not, then I have a lot of studying to do. Yeah. Okay, so or why not just like make it there and then increment it alongside, so we don't need to do this at all. Then we'll just say old array equals j, or old array j. which we'll set as our current value. So we'll set m items I equal to the value in the old array. I believe it said that you can actually make a list out of that. That's why I'm using it. I'm just following the book, what the book said. Like you can set the pointer value to the current value of the integer array. And we likely need to call delete on the old array since we're not using that anymore. Alright, let's see if I mess this up completely, or let's see if I got close. For the first two parts at least. I get okay, I guess they're returning -1, not 0. M items index. Okay, they did greater than though, not greater than or equal to. Let me see. And I guess, yeah, if you're setting a value at index 4, if you're getting the value of index 4, I assume it would be that. It would just be that value itself. So it doesn't need to be, it's not going to be greater than or equal to. And then let's see the insert, okay. Index. Import old array equals items. Okay, I remember that properly. Plus that count. And we're setting a new integer array of them counts. I'm sure like no one ever actually does this, but I guess this book just wants me to do it for practice. Phoenix equals I. Yo, what's up, Devendra? What's up, man? Yeah, if I got the gist of this, I can just skip to the next part. Val of M items I, old array J, yeah. I mean, looks like I did it right. I just want to see if I can actually like remember the constructs here that I need to do. But it seems like I do, so I guess we can skip to the next part. Which I believe this part is probably going to be linked lists. Probably stream for a couple more minutes and then end off, maybe. We'll see. Looks like I got the gist of it anyways for the list. Went to a conference and those are the 2 available hats. Interesting. Also got way too many stickers, dang, bro. I gotta go to one of those conferences. I've never been to one. Alright, this is probably just the linked list, so. Each node has a value and a pointer to the next node. Seems simple enough. I can probably just do this with structs, right, dude? I don't want to do it with a class. I'll probably just do it with the struct later. They're pretty much the same thing. Three single nodes, is there a new node data type? Value 7, 14, 21 for each node. There's a bunch. This book is C++ Data Structures and Algorithms by Vishnu Angaro. I've seen this book recommended a lot, so I'm just looking into it. Not that, here. And I really gotta get better with data structures. So, might as well go through this book and learn properly. Okay. A pointer, new node. So we're making a new node every single time. The Rust toggle is not good. That's unfortunate. Let's see. So you don't initialize the next pointer for all nodes, it'll automatically be filled with the null pointer. Okay. Yeah, we're just setting the values right now. So the data inside of the node will be the values that we set. Setting the next value as node, okay. As the next node that we have. Yeah, that's pretty straightforward. That's pretty straightforward for the most part. Okay, so now we're printing that. Yeah. Okay, so it's just iterating through the nodes that we have. All right, setting up each of our nodes here, like we saw before. Okay, this seems pretty straightforward so far. So you can always sort the data type to the value. Okay, okay. We're setting up templates to handle any type of data type here that we have. Okay. Yeah, those conferences seem very interesting to attend. As we're just passing in, it's basically the same as before, just passing in T. So we can use any data type that we need. Refactor the print node function to become a function template. Okay, that's okay. Interesting. So that's just your generic nodes there. Yeah, I remember this stuff from Python. Linked list from Python, but it's probably going to be a little bit different with the code implementation, but the general concept should be the same. More of a programming language guy, and I see tons of language conferences in Europe. Dude, that's interesting. I feel like once I get better at this stuff, I might attend some. That's gonna be a while from now, probably. Alright, so we have a node, the head. It's the first element of the linked list and the last element of the linked list. Yeah, it seems pretty intuitive. Pretty intuitive here. I assume if we're inserting it at the tail, we just have to look if the pointer to the next node is null or not, and probably just insert it at the end there. Attach that pointer to the current value that we're inserting based on the node. What's up, Galactic? Probably just about done streaming soon. But I appreciate you joining in. head is probably very easy to implement. You probably just have to look if the head value is there or not. Otherwise, just append it to the start. That's pretty simple. That one we already know. Most likely it's what I said earlier. Inserting at a certain index, though. Well, we need to probably take the value that's pointing to that node, the index we're trying to set into, and set it to the new node, and set that new node to the next value that we're putting in between before. Appreciate you, Galactic. Appreciate you joining in. I'll probably do more coding streams from now on, probably set up learning streams. I just wanted to test out and see how the learning streams go. I guess it was decent, not too bad. But probably I have more fun with coding on stream and then learning off stream. Template technique T. Wait, what are the other methods in here? I guess. Let me see. Why do you choose to learn C++? Just for some personal reasons. I just wasn't having much fun with Python or any other language like JavaScript, Python. I tried those, but I just wasn't having fun with it. Python was decent, I guess, but I'm having a lot more fun with C++. I just wanted to try it out and see. Coding Jesus did influence me to getting into it, and now I actually like it. And I wanted to get into compiler stuff. I just started a couple months ago, so we're still very iffy on it, but we're getting there eventually. Yeah, that is true, AJ Brady. That's true. UBs are friendly. I don't know, to be honest. I don't know why C. Why not C? I mean, I guess just the circumstances drove me towards C++. That's all there really is to it. Where'd you get that DSA PDF? I just looked for a GitHub on it. It's this one, and you can literally just search up books like data structures, algorithms. Just say GitHub at the end and it'll probably be there. Or did I just find this PDF randomly? Oh no, the PDF is literally just there, I guess. Let me see if this is the right one though. If it loads, it's not loading though. It should be the same, it has the same handle, 1801030. So it's literally just search it up and it'll come there, right here. And it's probably there on GitHub too. The book. I don't know if the book's there, but it might be. There's just so many books on GitHub that people just post the PDFs for. Same for this book. Entering a compiler. I found this book on GitHub. There's like a whole list of GitHub books there. PDFs. someone who could at some point contribute. It would have been nice to see more about Linux and less about Docker or AI. Yeah, that seems pretty insufferable to hear AI constantly. Kernel development. I think a cool thing is getting students involved in kernel development. Yeah. I'm just gonna go with this, but let me go back to our. Let's go back to the project here. Dude, I might need to add 64-bit support for the RISC-V because I do have complete. Well, not. Yeah, complete. Probably complete. It's probably complete, to be honest. Complete 32-bit support for RISC-V 32. So I don't know. I want to implement 64-bit. It's very easy to, but it's just so annoying because I have to go through this. I have to go through the switch case again and add these instructions based on their opcode and their func3 and func7, whatever fields they have, depending. And I've already done it like so many times. I don't know. I've done so many times already. I might just get AI to do it or something. And then I have to actually implement how they're actually represented in the interpreter. I guess this is a good practice probably to do it myself, but the decoder switch, I'd probably just do that. I'd probably just have AI do that. Yeah, I also don't trust it. I probably have to do the decoder myself. I can't trust it. Claude got the opcodes and the func3s and whatever other fields for some certain instructions. I got it wrong, and I had to like remind it that it's not. That's wrong, and that the documentation says this. That was when I was just like questioning AI for some little things. And then I just ended up saying, yeah, it's not best to rely on that. I'll just do it myself here for this. What is that? Rad debugger. Yeah, successfully vibe coded quotations. Oh, I haven't heard of that. Galactic. Yeah, it's really good at catching bugs. But yeah, when it comes to writing code, it's bad. But it could also really be bad in debugging if it's like very specification or documentation heavy. Like, I don't know, it understands RISC-V well, but for a lot of points it gets it wrong. Even when debugging my thing, it would give me like, it'd say like, oh, this opcode here is wrong, or this, you did this instruction wrong. It should be ALU result minus ALU result equals 0 or something. And then it said, oh wait, never mind, it's not that. I was wrong. And then I'd just be like, okay, interesting. It's 200,000 C program that compiles in 2 seconds. Interesting. What's up, Aduck? Yes, I am. Just finished the second year. Second year of college, just finished. Alright, what? Okay, let me see. Is it on Cornell, I think? Yeah, wait. No, not this one. Oh, dev interpreter. Oh, interesting. I didn't know they had this. Okay. Let me see. Let me just type this 5 here. Let me see. So we have support for all the 32-bit, but 64-bit, yeah. No, we have this one, but not 64-bit though. It's not many though. It's not many instructions. Realistically, I could do this in like an hour, maybe hour and a half, 2 hours, depending. There might be some more though that I'm not looking at. It's 5. Let me see. Not that page. This page. 64. Oh, they have 64-bit for float. Actually, not that much. It's only 4 instructions for 64-bit floating point instructions. And yeah, you can't post links galactic. I don't think YouTube allows that, sadly. Yeah, 8.com 2006. Risk 5. The double instructions would be. Oh, I totally forgot about double. Double is like a whole different paradigm. It's not really that much different, but it's just like a whole new set of instructions. I have to do all of these. They'd still be in the floating point registers though, so I wouldn't have to create any new registers. I'd still be operating on the same registers. Let me see some. So that is that. Oh, okay. It's the format fields that are different. That's why. 0, 0 for every single floating point, but for the double, yeah, 0, 1. That's what distinguishes between double and. I mean, that's not too hard, right? I can literally just copy paste. It should be the exact same. It's just the formatting to change, the format bits that change for that. Pretty sure I can just copy paste most of that. And then the 64-bit double. Just a couple more to add on there. A couple more instructions here than these. Already the ones here in the 64-bit double. Just a couple extra extensions. Oh, and then the control. We don't necessarily need this right now. We may later though, if we do a vectorization, but I'm not sure if we need it now. I'll probably implement 64-bit at some point. Oh, that should be good. All right. Not galactic. It didn't post the link. It shows on your side that you posted the link, but it doesn't post it to anyone else. Yeah. That's YouTube's feature right there. What is it though? What link are you trying to send? Oh, for that C project, yeah, that you're talking about, yeah. I remember now. The C debugger, the C debugger that was written in C, I believe. It is 12:47 a.m. I feel like we're at the end here. End here for the stream, to be honest. Not really much I want to do. Probably just chill out for the rest of the night and then go to sleep. So I'll probably end this stream here. We had surprisingly a decent bit of people here chatting. Swan, Max, Adrian Brady from Kaio. We had the Black Market guy from earlier. Galactic, Brady, Slow, Slava, A-Duck, Not a Sandworm, Exo, and a couple other people. I appreciate you all for joining the stream, and I think I'm going to end it right here. I appreciate you all. Have a good night, everyone.